We're going to talk about circle theorems. The question that was on circle theorems was answered most poorly. Only two of you got it correct. I don't know if those two people are in this class, but if you did, well done. But if you didn't, this is for you. And even if you did get it right, it might just be a refresher. Might help you just remember some things that might come up. So a couple of rules that we need to just remember before we go into circle theorems. Angles in a quadrilateral add up to 360. So that one, that's 90, that'd be 50, that'd be 130. Then in a circle, if we have two radii, they're going to be the same length. So this length is going to be the same length as that. And you'll see questions very repetitively test you on isosceles triangles or something related to that might need that piece of information. The other rule that I tend to see come up quite often is the opposite angles rule. So just be aware of these three. These aren't circle theorems, but they're just angle rules that we just need to remember. So they're quite basic, but just to keep you aware. I'm going to quickly run through the circle theorems. So I would recommend if you've got a glass around you or something circular, you could just draw a couple of circles and say draw 6, and that should be enough. And we're just going to quickly run through the circle theorems. I'll explain them very briefly. Circles down and just make sure you understand what the diagram is showing you. So once you've drawn your first, I'd say 6 circles is okay. I think that'd be enough. If we have a line that is a tangent to a circle, tangent just means it's touching the circle at one point. We have a radius, so center of the circle to the edge, that will be 90 degrees and that will be 90 degrees. So just remember, if you've got a line that touches a circle, that'll be 90, that'll be 90. That's the first one. If you want to write that down, that's how you would remember it, but you can just remember if there's a tangent, it's going to be 90. Second rule, if we've got a semicircle, that's a semicircle, half of the circle, and we've got a triangle within that circle and one of the sides is a diameter, that means the angle that's not on the diameter will be a right angle. So an angle in a semicircle will be 90 degrees. That's quite important. Just give you 20 seconds just to get those two down. I'm going to go through these quite quick so that we can do the practice. We can spend more time on them, which I think will be more helpful to you. And if you have any questions, feel free to ask me, whether they're related to circle theorems or something else, but we'll be going through the topics that people struggle with in the test. Okay, next one, angles in the same segment are equal. So the way I like to remember this is it's a bow tie theorem. So if you see this bow tie, this is a segment, that bit there, the large part of that circle. These two angles are going to be equal to each other. So if that is 50, the angle would be 50 degrees. So just look out for a bow tie, and these two angles will also be equal to each other. Second rule is if we've got this arrowhead shape, or sometimes you might see it a little bit differently, it might be drawn like that. It might be drawn a little bit different, but this is the main way that it normally gets tested. The angle at the center is twice the angle at the circumference. So that just means that if this angle is 50, then this angle would be 100, and same the other way around. If this is 100, that'd be 50. The way that you can remember it, because sometimes some students forget which one is more, if you have a city, let's say for example Edinburgh, there's going to be more people in the center of the city than there are going to be on the outer edge of that city. So just get those two down. You can put them on the same circle if you want to, if you haven't drawn so many, but just have those two down. Also, there's been a few occasions where sometimes my screen will just stop sharing. Just let me know if that happens, and then I'll redo it. Okay, next question. Next circle theorem is opposite angles in a cyclic quadrilateral add up to 180. So what does that mean? It means if we have a four-sided shape with all of the edges touching the circle, that means it's a cyclic quadrilateral. It's touching the circle. And the opposite angles will add up to 180. So these two will add up to 180, and these two will add up to 180. And obviously, because it's a quadrilateral, they're going to all add up to 360. So if this one was 100, this one would have to be 80. And let's say this was 60, that one would have to be 120. So just remember, opposite angles in a quadrilateral, if it's inside a circle, add up to 180. Give you 10 more seconds just to get that down. And if we have tangents from the same point, that means that these lengths will be equal to each other. So sometimes you might see two tangents and there might be a line there, and that just means that's going to be an isosceles triangle. You also know that if there's a radii and it's joining there, that would be a right angle, that would be a right angle. Okay, we've got this question here. We're going to have to use two circle theorems. I want you to try and think which rules are you going to have to use. So I'll just move that so you can see all of the rules. How are you going to find this angle? I'll give you 10 seconds just to think, and then I'll give you a clue, and then I'll tell you the answer after another 10 seconds. So just try and find the value of that, and all of the rules are on the right hand side. My first clue is we have a cyclic quadrilateral. So that will tell you something about this. That's going to be 80 degrees. And then the second thing that you're going to have to do is angles at the center will be twice this one. So because this was 80, that will be double it, that will be 160. Okay, the next question, this one's a little bit simpler. I'll give you 10 seconds to tell me what it is. You can type your answer in the chat. Don't press enter yet. What would that angle be? Very simple. And you can press enter in 3, 2, 1, and go. See what you get. No, it's not 60. The 60 would be this one down here. This one at the bottom would be 60. That would be 70. Obviously, if you worked out angles in a triangle, you could find that angle. You could find that angle. You could also find that angle using straight lines. But yeah, that would be 70. This next one, have a think. What would you have to do first? There's two angles you're going to have to find first before finding it. And the major clue is that it's a tangent. I'll give you a clue in about 10 seconds. You can use, no, I think you could do this in your head or just write it down. It's a non-calculate paper, so just try it without. That's my clue. So it's a tangent, so that angle will be 90. That angle will be 90. I'll give you one more clue. Type in your answers in the chat. Don't press enter yet. Just going to work it out in my head. Okay, I've got my answer. You can tell me what your answer is in 3, 2, 1, and go. Or if you've not got an answer, just type in N. 120. I don't think it's 120 because this is a 5. So I know it's going to end in a 5. Go through this one slowly because I don't feel like people have an answer for it. 115, let's see. So the clue that I gave you is that this is a tangent, that's a radius, so that will be 90 degrees, and this will also be 90 degrees. Quite similar to the question in the test. So far we've got these two that are 90, and then I drew around the shape. So whenever you're doing these questions, always look out for quadrilaterals and triangles, because they're really the only two shapes that come up in these questions. We've got quadrilaterals, so all of them are going to add up to 360. So far we have 65 plus 90 plus another 90. So that's 180 plus 65, so that's 245. And if we take it away from 360, we get 115. So yeah, Cameron, well done. Flaming Cookie were close. There's going to be a couple of rules you're going to have to use to find this one. I'll give you a clue in a few seconds. Just have a think what you could do. Could do it in 2 steps, this question. Okay, so my clue is we have a semicircle here. Okay, type your answer in. And press enter in 3, 2, 1, and go. Nice one, Jack. So, alright, Flaming Cookie. I'll go through it together. So we had a semicircle. So my clue was, because this is the diameter, this, and we've got a triangle, this angle will be 90 degrees. And I'm going to draw it in another pen so you can see it a little bit more clear. This triangle here, we have two of the angles. That's 20 and that's 90. 20 plus 90, which is 110. Take that away from 180 because it's a triangle. That would be 70. So well done if you got that one. Another type of question that normally comes up is you might get asked to work out this angle, and you would just have to spot, I mentioned it before, these two are radii, so that means that this is an isosceles triangle, and the base angle, so the line that doesn't have the same sides, these two, this is the base, that angle will be 20, and then you could work out that one because it's isosceles. Take it away from 180, so that would be 140. That's a straight line, so that would be 40. If you remember before, that's 90, so 90 take away 20 is 70, and you could find it out that way as well. 70 plus 40 is 110, and that's 70. And you can also see that, I'll do it in a different color, this is also isosceles triangle over here. AOC is isosceles. Okay, the next question. Have a look at it, think what you could find first. Normally, if you're not too sure how to get the answer straight away, just think what angles could you find first. You don't have to get the answer straight away, but just try and think what angles could you find, or think if you have this one, how could you go backwards to get to that one. There's two ways you can think about it. I can see how you've got 64. So Jack says 32 and Flaming Cookie says 32. The answer is 32. I'm going to show you why 64 is wrong. I think you missed one step, Cameron. If it's isosceles, this is telling me that PR is the base. That means that these two angles are going to be the same as each other. So I'll just draw it out here. This is my isosceles triangle, and I know that this angle is 116. I do 180, take away 116, and that's where you got the 64. I need to divide that by 2 to split it between those. And then the next thing, you can go straight to this once you've found that one. You've got angles in the same segment. It's the bow tie theorem again. So this one will be the same as this one. Okay, next one. Have a think about it. I think this one's a little bit tricky. There's 1, 2, 3. There's 4 steps to this question. I'll give you 1 minute, but I'll give you some clues whilst you're working on it if you're stuck. First thing I'll tell you, or give you a clue on, what could you work out first. So I would probably do this one first, and then I would do this one, and then I would do this one, and then that will give you this one. So 4 angles you need to find here. You can do it in a different order, but that's just the way that I would do it. Okay, I'll start to give you some clues. First clue is this is a tangent and this is a radius. If you've got an answer, just type in Y so I know you've finished, and then I won't wait around. But if you have no idea, just type in N. Okay, cool, Jack. Just give everyone else a little bit of time. Okay, let's go through it. So the first thing that we need to do, well, can do it in any order, but this is a tangent, this is a radius, so this angle is going to be 90 degrees. So I can find this missing angle, 90 take away 56, That's going to be 34. The second one that I said you could find, I think I would go with this one. You've got angles around a point. I don't think I've mentioned this so far today, but angles around a point add to 360. So these two add up to 360. So 360 take away 130 equals 230. So that angle is 230. Then if you take a look, here we've got this arrowhead shape. So this angle is going to be double this angle. So 130 divided by 2, which is 65. And then the last one, I think this is a little bit tricky to spot, but we've got a four-sided shape here. It's 1, 2, 3, 4. So far we have 65, we have 34, we have 230. Just add them up. So that's 329, and B would be 31, because you just have to do 360 take away 329 to give you that 31. So in your test, these questions are normally a couple of marks. So even if you don't get the final answer, I think you could probably get at least a few. I think the hardest one to spot here is probably that one. I think that one's quite obvious and that one's quite obvious. Maybe this one's not so obvious to some of you, but definitely put in some of the work working out. Jack, did you get the answer? Cool, well done. Right, I think this is the last rule. This is probably the hardest rule to spot. It's called the alternate segment theorem. So we have a tangent and we have this chord. It's just a line that cuts through the circle, not at the center. So we've got one angle over here between the tangent and the chord, and that's going to be equal to this angle. And the way that I like to remember it is this line. So this angle, I'm not going to have this or this angle that's going to be the same. It's going to be the one that's not got anything to do with this one. That's the easy way to remember it. If you take a look, this angle, it has nothing to do with that orange one. It's an easy way to remember. So if this is 50 degrees, that would be 50 degrees. Just make a note of that. So you've got an example, but it's probably the hardest one to spot out of any. I think you're very lucky in Scotland that you don't have to remember the rules. Give you 15 more seconds just to get that down. Right, let's take a look. So we've got this question here. I'm going to give you 30 seconds to have a go at it. I think because I'm not testing you on your arithmetic or anything, you can use a calculator just to make it quicker. I want you to think, how would you find Z? If you do find Z, you can find this angle here as well. It's going to be using the rule that we just saw, and quite a basic rule you learned a few years ago. Just 30 seconds. If you got an answer, type in Y. Gonna put a clue in. Flaming cookie on it. Very good. Can find that other angle. It's quite a simple one, but it's the only one I can think of finding. Cameron, how are you doing? Alright, let's go through this one. So we've got alternate segment theorem. I've put those two lines on so it's obvious. That's 52. That one's going to be 52. Got a triangle, so add them up together. That'll be 112. So 180, take away 112, which is 68. If you did want this angle, you would just use angles in a straight line, but I won't explain that. You can just figure it out. Right, next question. This is probably something similar to what you're going to get in a test. And it's given you some suggestions which angles you can find. So you can find A, B, C, so A to B to C. You can find that one first, and then A or C. A or C, you can find that one next, and C, A, E. You don't have to do it in this order, but this is just what they recommend. So you're trying to find those three angles. give you 1 minute. If you've managed to get all three, just write Y in the chat so I know you're done. Or if you get stuck on one, just write, let's say you only managed to get 1 out of 3 of them, you're not sure how to get the other 2, just write 1 out of 3. Or 1, you can just write 1 or 2 or 3 if you've finished. To show me how many you've done. Okay, Flaming Cookie's got 2. I'm gonna guess Flaming Cookie is the one that you miss in that one. Yeah, okay. Give you a clue for that one to make it more obvious for you. Oh, Flaming Cookie's got it. This is my clue. Do it in a different colour. Okay, let's go through these. I think most of you are done. So ABC, we've got a cyclic quadrilateral. So these two add up to 180. Then AOC, this one over here, is 136 because it's going to be double that one. And then the last one, CAE, it's the hardest to spot, but it's the easiest to work out. It's going to be exactly the same, alternate segment theorem. Just write a score out of, like if you did 2, write 1 out of 2, 0 out of 2, 2 out of 2, just so I can see what you got. Or if it's out of 3, 0, 1, 2, or 3 out of 3. Okay, cool. So I think if you're not too sure, always look out for alternate segment theorem. I think that's the hardest one to find. Okay, this will be the last one before we look at the one that came up in the test. I'll give you some suggestions on how I would approach it. I would probably do this one first, and this one second, and this one third. If you've got an answer for all three, just type in Y. If you're stuck, just type in how many you managed to find. Okay, Flaming Cookie first. Give everyone 15 more seconds. Flaming Cookie, just check your answer, maybe add them all up, see if they make 180. But okay, we got everyone that's got it. First one that I would go for would be this one. This one, you have to be very careful. It looks like it's a tangent, but this one isn't a tangent because the line is not a radius. This isn't a radius, this is just a chord. So you don't put 90 anywhere here. So this one is a cyclic quadrilateral. So we find that one with 77. Pat on the back if you got that one. Then the second one, I think this one's easiest to work out, but hardest to spot. It's 39, alternate segment, and then you just got triangles to take it away from 180. So 64. Just check your answer. All of these should add up to 180. Okay, this is the question that came up in the test that was answered quite poorly. I don't know how many marks you would have got because I can't see how much working out you did, but I'm just going to show you how I would approach this in a test. Diagram below shows a circle center 0. Okay, I could draw that these are going to be radii. Actually, not on that one. On this triangle, I could draw that these are radii. So I'm just looking, can I put any more information onto the diagram whilst I'm reading? AC is a tangent to the circle at the point B. A to C is tangent at the point B, and I know that this is a radius, so I can put 90 degrees in there, put 90 degrees in there. That one's done. CE is a tangent to the circle at the point D. Where's CE? So CE is here, C to E, and this is again a radius, so I can put 90 degrees there, and that whole bit will be 90 degrees. DG and BF are diameters of the circle, so DG, D and G is a diameter, and BF is a diameter. So we have a semicircle, but we don't have a triangle in there, and we have a semicircle, but we don't, so that's not really going to help us. Angle DFE is 125, and DFE is already on, so we can't do anything with that. So now we're going to start to think, what could we find out first? We're trying to get to here, so we're going to slowly progress through the diagram, probably go in this direction. So the first thing that I can see, I've got angles on a straight line. So I could find this angle, 180 minus 125 would be 55. And I already drew on that this is an isosceles triangle. So this is why it's helpful to draw on things whilst you're reading the question. That one's 55, so that one's going to be 55. Then I've got angles in a triangle, this bit over here. So 180, take away 55, take away 55, so take away 110, which is 70. So this angle is 70. Then remember what I showed you before, opposite angles are equal. So I could put that is 70 as well. We've got angles on a straight line. So this will be 110. And now, if we just concentrate on this shape, OBCD, it's quadrilateral. So we have a four-sided shape that's going to add up to 360. 360, take away 110, take away 90, take away 90, which will be 90 degrees. This is that right? 180, no, 70, sorry, looked wrong. I added those two up wrong. So when you're reading the question, just put in information into the diagram, then slowly work things out. Put your working out onto the diagram, so even if you make mistakes, even if you continue on with that same mistake, you'll still get some marks. And you'll get some marks for the ones that you've worked out. That's how we'd approach it. I'm gonna, in the same folder that you found the test, I'm gonna put in some homework so you can practice these kind of questions. The next thing I'm going to talk about are these two questions. I'm not going to do a lot of work on it, but I'm just going to explain how we do these type of questions so that when you see them, you'll hopefully be more used to it. Straight line has equation. So these are from the test. These are the ones that were answered poorly. Straight line has an equation, x plus 4y minus 24 equals 0. Find the gradient of this line. First thing I need to remember, if I'm trying to find gradient, I want equations in the form y equals mx plus c. I want y on its own and everything else on the right hand side. So it looks something like this, and it's a little bit easier to find the gradient and find the y-intercept. The number before the x is the gradient. Sometimes I think in Scotland you refer to the c as b, but it's the same thing. C is the y-intercept. Where does it cross the y-axis? The gradient is how steep the line is. The y-intercept is where does it cross the y-axis. So the first thing I can see, this is in the form y equals mx plus c. So I need to try and make y the subject. So if you're good at rearranging equations or making stuff the subject, you'll be okay with this. If you're not too good at it, I'd work on that skill, and then you'll be able to do these kind of questions easily. First thing I'm going to do is move everything apart from this 4y over to the other side. So I'm going to move this x and this minus 24 over to the other side. So to get rid of this x, I'm going to take away x, and I need to add 24. So now I've got 4y is equal to, I'm going to write it as 24 minus x. So I moved that minus 24, I added 24, I moved that x, I've taken away x. And it's still not in the form y equals because I've got this 4 before the y. So I need to get rid of this 4. Y is being multiplied by 4. So I need to divide everything by 4, and that'll make it y on its own. So I'm dividing everything by 4. So on the left hand side, it's going to leave me with y. 24 divided by 4 is 6. And x divided by 4, we just write it as x over 4. That means x divided by 4. Now I can find what these two bits are. It wants the gradient, so I'll do the gradient next, but I'll just talk about this question. So the y-intercept is this bit on its own, this constant. It doesn't have a x next to it. So if I needed to find the y-intercept, I don't need to find it here. C is 6, or the coordinate for that would be 0, 6. So we would cross over here at 6. The next thing I can see, it's x over 4. I can rewrite x over 4 or minus x over 4 as negative 1/4 x. I've just brought this divided by 4 outside. So I'm just going to rewrite this as y equals 6 minus 1/4 x. So the gradient is this number and this sign before this x. So m is equal to negative 1/4. So the gradient is negative 1/4. So the line would look, it'll be quite shallow because it's a small number. It's less than 1. That line would look something like that. That's the answer that you want. So if you found this question tricky or you found it hard to follow along, two things I would revise is gradient and y-intercept, and rearranging. I'm not going to spend too much time on it today because this was answered a little bit better than the other questions, but if you want to spend some time on it on your own, you can look at those two topics. Next question, I've got expand and simplify fully x on the outside multiplied by x to the power half plus x to the negative 1. Just give a simple example. If I have x squared times by x to the 3, I think everyone will probably be okay with this. Might say x to the 6, but remember, if we're multiplying and we have the same base, we just add these two together. So we have x to the 5. So we're going to think of this same concept when we do this. Here we have x, and there's an invisible 1 here, multiplied by x to the half. And I'm going to think of this 1 is the same as 2 over 2. So I'm doing 2 over 2 plus 1 half, because I'm multiplying them together. So that times by that would give me this one, plus 1 add negative 1. So 1 plus negative 1, that's 1 plus negative 1 is going to be 0. So I've got x to the power of 0. So let's simplify both of these. 2 halves plus a half is x to the power of 3 over 2. So this one I can't simplify all. And then this one I can simplify. One of the facts that you need to know is anything to the power of 0 is going to be 1. So here we have something to the power of 0. This will be 1. The other fact that you need to know is anything to the power of 1 is going to be itself. So those are just two rules that you need to remember. So I'll just explain what I did again. I'm multiplying everything outside the bracket by everything inside the bracket. I put that invisible 1 just so that it's obvious what I'm doing. Because I'm multiplying, I add them together. I can't do 1. I could write it as 1.5, but it's better just to write it as a fraction. So I did 2 halves add 1 half to give me 3 over 2. 1 add the negative 1 gave me 0. And x to the power of 0 gave me, simplifies to make 1. And I can't simplify that, so I leave it like that. That's my final answer. Got about 15 minutes left. So those are just two questions I just wanted to explain. If you want to practice that, I would look at indices. And if you struggle with the fractions bit, you can look at fractions as well. Maybe your index laws, just in case if you want to practice that a little bit more. But I'll set you some homework just to practice all of these topics that we covered today. Next thing that I want to talk about is, I think it was this question, which was answered quite poorly. I think only one person got it correct. So eventually I'll get onto that question, but we'll just build some knowledge up before we get there. So two shapes are congruent if they're exactly the same as each other. So all the sides of these triangles are the same and all the angles are the same. And two shapes are similar if one is a multiple over another. So the angles will be the same. You just need two of the angles to be the same because the other angle will be the same. So all the angles will be the same, but the side lengths will be different. That means they've just been multiplied by something or divided by something, like a scale factor. Yeah, it should say they are similar. It's been multiplied by a scale factor or something. So we're going to do a very basic example and then we'll lead up to working towards this question here. So a couple of ways you can do this. One way is you can look, we've got these two shapes that are similar. That means they've been multiplied by something to get from one to the next one. You can either look at what has this length been multiplied to get to 8. So I can do 8 divided by 5. So it's been multiplied by 8 over 5 to get from there to there. Or you could also look, I'll do it in a different color so you can see the different method. Because I can see that this base is matching up with this 12, I could think, how has 8 become 12? What have I multiplied by? So 12 divided by 8. Simplify that, so that divide both of them by 4, so it would be 3 over 2, or 1.5. And multiply them both by 1.5. So I can either do 5 times by 3 over 2. It's the same as 5 over 1 times 3 over 2, so 15 over 2. That gives me this. Or I could do 12, and I could use this one, where I looked inside the shape, and divide it by 8 over 5. So 12 divided by 8 over 5. And if you know how to divide fractions, you're doing 12 times by 5 over 8. You can cross cancel. So both of these divide by 4. So that would become 3. That would become 2. 3 times 5 is 15. And it's 15 over 2. So two ways you can do it using the scale factor method. You can look inside the triangle, or you can look outside of the triangle. There's one extra way, sometimes some students prefer it. You can create an equation. I'm going to write 12 divided by 8 is equal to x divided by 5. So I just look at the matching sides and I create an equation. Then I just need to solve this equation. So cross multiply, 12 times 5 is 60. 8 times by x is 8x. So I need to solve this, divide both sides by 8. 60 over 8 equals x. And if you simplify that, that'd be 30 over 4, 15 over 2 again. So I gave you three examples, 3 ways you can do it. Look inside the shape, look outside of the shape, or create an equation. There's 3 different ways you can do it. It's entirely up to you. And just make a note of whichever method you prefer, and then we'll spend a few minutes just practicing that. Just give you 20 seconds, just make a note of it. Okay, let's try it with these ones. I'm going to suggest, so you've got 3 options. You can either look at these 2, you can look at these 2, or you can create an equation. It's entirely up to you. And try and do it without a calculator, because the question in the test was without a calculator. I think for me, because I can see 10 and 15 are quite similar to each other, I'd probably go with using these 2 numbers. 15 and 18 might be a little bit trickier, but it's entirely up to you. Does that really matter? I'll give you 20 seconds to get number 1 done, and if you finish number 1 you can move on to 2. It's 12. We'll check that in a second, Cameron. But yeah, it might be 12. I'm going to start doing the working out. I'll show the 3 methods that you could use. So I would do 15 divided by 10. 15 over 10, which is 3 over 2. So I need to divide 18 divided by 3 over 2, which is 18, 20, 36, 12, yep. Or you could have done 18 over 15, which is 6 over 5, and 10 times by 6 over 5, which is 60 over 5, which is 12. Or you could have done 18 over 15 is x over 10. So any of those methods would be fine, whatever you're comfortable with. I think you'll probably be doing the next one. I think this is going to be a decimal or a fraction, because the numbers don't look so nice. I think I'd probably, for me, I prefer to use the inside of the shape. I look at that relationship. So it should be, and another way that you can check this, you can see that 40 is more than double 17. So our answer should be more than double 11. It should be around 25 or something. So that's a little clue of how you can check. So for this next one, I'm going to do 40 over 17. I need to multiply that by 40 over 17. Can't simplify that, unfortunately, so it would just be 440 over 17, and you can leave your answer like that. That'd be fine, unless it wants it as a decimal or whatever, but I doubt it would. So you can leave your answer like that. I won't go through these, but if you want to, I'm going to put this PowerPoint in the folder so you can have a look. This one is going to test your knowledge on Pythagoras, so it would be a good question for you to try. I'm going to look at this question now. I'll go through it and then you can try one. So if you've got something like this where you've got 2 triangles, first thing that you should do is draw both triangles out. So I've got this little triangle here, and then I've got this larger triangle on the outside, and just draw both of them out. So I'll do the small one first. That's 4. I don't know what that is. That's what I'm going to have to try and find. And then I'll do the larger one. 4 add 6 is 10, and that length is 7.5. So I'm going to look at that relationship from 7.5 to get to 10. 10 over 7.5, which is 4 over 3. So I need to divide. Cheers, Cameron. I thought it'd happen. It's a shame it happened in the last few seconds. Should be back. So I would look inside that shape. I did 10 divided by 7.5, divide them both by 2.5, so you get 4.3. So from the x to get to 4, I times by 4 over 3. To go the other way, I need to divide by 4 over 3. No problem, Cameron. Thanks for letting me know. So you're doing 4 divided by 4 over 3. So 4 times by 3 is 12. 12 divided by 4 is 3. So x would be 3. So main thing, just draw out both triangles, look at the relationship either within the triangle or within the same sides, and then you can find it. I'll let you do these for practice, for homework or revision, whatever you want to call it. And let's look at this question. So this is the one that came up in the test. First, I'd recommend drawing out both triangles. And you are trying to find BD, which is that length there, which is just part of that large triangle. I'm going to do it slowly at the same time as you, but you can have a go at it first. I've drawn out both of the triangles. Look at the relationship between the 10.5 and the 7. So this is testing you on your simplifying fractions, division of decimals as well. I think that's why it makes it a little bit harder. And be careful because you only want BD. You're not looking for AB, you're looking for BD. If you've got an answer, you can type in Y and then I'll go through it. I think a lot of students would go from 3 to 7, which I think is a little bit trickier than going from 7 to 10.5. So just choose whichever method seems better. I think 7 to 10.5 is a little bit easier. So to get from 7 to 10.5, I've times by 10.5 divided by 7. I need to simplify that, so I get rid of that decimal, times both of them by 10. So this is looking at knowledge on simplifying fractions or converting decimals to fractions and stuff like that. So it'd be 105 over 70, and I can spot that both of these divide by 35, so that'd be 3 over 2. If you didn't spot that, you could divide them both by 5, and then you'd eventually get to 3 over 2 anyway. So now I know to get from there to there, I've times by 3 over 2. I need to do the same thing to the 3, so I can find this side. 3 times by 3 over 2. 3 times 3 is 9. And 1 times 2 is 2. So I've got 9 over 2. That's 4.5 or 4.5. That's not my answer. I'm going to put that onto the diagram so I don't make any mistakes. So I know AB is 4.5. I need to find BD, and I've drawn that on so I know which one I'm trying to find. Always put it on. So I'm doing 10.5 minus 4.5. That'll give me my answer, which is 6. Okay, that's the end of today's session. I was going to do completing the square, but obviously you can see we've got a lot to go through. The PowerPoint is in the same folder, so if you just go to that same link that you got given, you can have a look at this PowerPoint and look at the other questions, and I'll also set you some extra circle theorem stuff, some extra I won't set you any similar triangle stuff because there's enough practice in there for you to do. So I'll just set you some extra circle theorem stuff, and I would look at the completing the square questions, try and figure out how to do it. I don't think it's too tricky once you have a look at a few other examples. If you have any questions, I'll stay here for a couple of minutes because I'm free for about 5 minutes. But if you have to go, you can go, and I wish you all good luck if I don't see you before your exam. No worries, Cameron. Thank you very much, Flaming Cookie.